Good morning, afternoon, or evening, cats and dogs. This video is going to focus on the lesson 6.4 guided notes, picking up where we left off previously in class. We would have seen up through question 11. We're going to finish these guided notes beginning with question 12, but I want to see one independent practice problem first. Some classes did see this in class, some did not. So if you've already seen this, go ahead and skip over it. But here's what I want you to do. I want you to try the question 9 minus 5j equals negative 6. You're going to pause the video and try it, but before you do that, don't forget, anytime the variable comes after subtraction, add the opposite. All right, give it a try. Okay, hopefully you tried this problem and hopefully you remembered that anytime the variable comes after subtraction, we should add the opposite and rewrite this as 9 plus negative 5j equals negative 6. Now, we need to get rid of this plus 9. The inverse of that is to subtract 9. Negative 6 minus 9 is negative 15, so we get negative 5j equals negative 15. Now divide both sides by negative 5 to get our final solution of j equals positive 3. Now, I have had some students who get positive 3 for their solution, but their work isn't the same. For example, I will have students who add 9 to both sides. That is not the same as subtracting 9. Now, if you add a negative 9 to both sides, that's great. But if you add 9 and somehow you get negative 15 here, that's not correct because negative 6 plus 9 isn't negative 15. And so what I'll have is students who will do negative 6 plus 9. I think sometimes they often have 15 here. They have a 5j and they do 15 divided by 5 to get 3 for their solution. If your work is not equivalent to mine, it doesn't mean that you are correct. So you really want to be careful when you're showing your work for these problems because I often will have students who show the wrong steps but happen to get the right solution because of a couple of mistakes that they made. All right, let's try some more practice with this. So these questions are going to be two-step equations, but we're going to have to simplify first. So number 12 is already done for you in your guided notes. 8x minus 16 plus 8x equals 16. Start by adding the opposite. Anytime you're going to simplify or combine some terms, you should add the opposite. So I rewrote subtracting 16 as plus a negative 16. And then I put my like terms, 8x and 8x, side by side and combine them. 8x plus 8x is 16x. So in this step right here that I'm going to draw an arrow to, we end up getting a two-step equation. And that's our goal, is to get either a one or two-step equation once we simplify. And so 16x plus negative 16 equals 16. The first step I want to do to solve that is get rid of the plus negative 16 by adding 16 to both sides. That will get us 16x equals 32. Then the inverse of multiplying by 16 is to divide by 16. So we end up getting x equals 2 for our solution. Now, you can check your solutions here. It's a little trickier. You'd have to do 8 times 2 minus 16 plus 8 times 2 and hit equals. It's really easy to make a mistake, so always double check that. It does get me 16, which is this number on the right-hand side. All right, let's try some of these. So number 13, we have 12a minus 14a equals 8. 12a minus 14a is negative 2a. Now, you can always add the opposite here, even though the like terms are side by side. So we have 12a plus negative 14a. If you choose to add the opposite, that will still get us negative 2a equals 8. Now it's just a one-step equation. The inverse of multiplying by negative 2 is to divide by negative 2, so we'll show that on each side. 8 divided by negative 2 gets us negative 4 for our solution. If I want to check this, I'm going to do 12 times negative 4 minus 14 times negative 4, hit equals. My calculator gives me 8. In fact, I just did that, and it worked. All right, number 14. We have 6 equals negative y plus 42 minus 2y. So I'm going to start by adding the opposite here since I do have subtraction. And I'm going to write negative y as a negative 1y. So you're going to see that I rewrote this guy as negative 1y. I rewrote minus 2y as plus a negative 2y. Now put your like terms, negative 1y and negative 2y side by side, and combine them. So I'm going to add negative 1y and negative 2y together to get negative 3y. So I have 6 equals negative 3y plus 42. Now subtract 42 from both sides. We've got a standard two-step equation. The inverse of adding by 42 is subtract 42. 6 minus 42 is negative 36. So I have negative 36 equals negative 3y. Finish by dividing both sides by -3, the inverse of multiplying by -3, to get y equals 12 for our solution. All right, let's take a look at some more. Number 15, b plus 8 minus 3b equals 18. Rewrite this as 1b plus 8 plus -3b equals 18. Now put your like terms, 1b and -3b, side by side. So I have 1b plus -3b plus 8. 1b plus -3b is going to get us -2b. And now it's just a two-step equation. So get rid of this plus 8 by subtracting 8 from both sides. We get -2b equals 10. And I know I'm going through these quickly, so don't be afraid to pause the video at any time to jot all this down. Finish this problem by dividing both sides by -2. That's going to be the inverse of multiplying by -2, and you should get a solution of b equals -5. We get that by taking 10 divided by -2. All right, let's take a look at number 16 and 17. So number 16, we have 5 plus 2p plus 8 equals -11. Let's put our like terms side by side. Those are actually our two constants in this one, 5 and 8. So combine 5 and 8 together to get 13. Now you just have a two-step equation. Start by subtracting 13 from both sides. Be careful, -11 minus 13 is not 2 or -2. It's -24. Divide both sides by 2. Take -24 divided by 2 to get your solution. You will get -12. All right, let's take a look at number 17. This is just a standard two-step equation, but our solution is going to be a fraction or decimal. So I want to point out that you will sometimes see problems like that, and that's okay. Let's get rid of that subtracting 9, and let's add 9 to both sides. And I forgot that this was still in here. This is not my first time making this video. It did not record the first time, or at least it didn't record any sound. So ignore this. I didn't delete it, but this somehow I copied it over from question 16. You're going to see it a few times, so ignore it. The inverse of subtracting by 9 is to add 9. -12 plus 9 gets us -3. So we have 6c equals -3. The inverse of multiplying by 6 is to divide by 6. So in your calculators, make sure that you're working top to bottom. So you want to do -3 divided by 6. Division is not commutative. And you end up getting a solution of -0.5 or -1/2. So you can choose to write your solution as a decimal or as a fraction. Some of you, your calculators will give you a fraction, some will give you a decimal. It doesn't matter, they're equivalent. All right, number 18. So I apologize, you're going to see this step again. Let me cross it out and get rid of it. There we go. So we have -15 equals 5b plus -12. The inverse of adding by -12 is to add a +12. So we do -15 plus 12 to get -3 equals 5b. The inverse of multiplying by 5 is to divide by 5. So you're going to do -3 divided by 5 in your calculator, and that's going to get you -3/5 or -0.6. So actually, if I do a problem like this and I see -3 divided by 5, I know that that's just -3/5. But if you divide in your calculator, it's probably going to give you a decimal. Both of these are acceptable answers. All right, let's move on to some word problems here. We will, by the way, see some more practice problems on these two-step equations that involve simplifying, or maybe that give you decimal and fractional answers as well. All right, so these questions ask us to translate each sentence into an equation, do not solve. These are going to be two-step equations. We've already done this with numerical expressions, algebraic expressions, and one-step equations. Let's see some two steps. Number 19. 6 more than. Remember that the phrase more than is going to represent addition for us. Twice a number means 2 times that number. So this is going to be 2 times something. And a number is going to represent our unknown. So we'll choose a variable like n. And don't forget, the word is represents our equal sign. So let's put this together. We've got 6 more than twice a number is 6 plus 2 times n, or 2n, equals -20. Number 20, 18 is. Remember that is going to represent our equal sign. 6 less than. Don't forget less than is going to represent subtraction. We'll talk about that in a moment. 4 times a number. Times obviously is multiplication. I'm not going to highlight that. A number is going to be our unknown. So we'll use the variable n. Any variable works though. So 18 equals, but then we have 6 less than 4 times a number is going to be 4n minus 6. Remember, for less than, we switch the order around. Since if it's 6 less than something, we need to take 6 away from whatever that something is. In this case, 4n. All right, number 21. The quotient of a number and 5 increased by 8 is equal to 14. So quotient definitely is going to mean division for us. A number is our unknown. So we use the variable n to represent that. I'm going to try to type some of this in, but I don't want to make it too confusing. So quotient is division, a number n and 5. So we're going to take n divided by 5. Increased by 8. Increased by represents addition, kind of like more than from number 19. Is equal to, obviously is equal to is going to be our equal sign. I'm not going to type that in. So the quotient of a number and 5, n divided by 5, increased by plus 8, set it equal to 14. There we go. Number 22, 4 more than 3 times a number is negative 26. So more than is going to represent addition. We saw that up here. 3 times a number, remember a number is our unknown or our variable, is represents our equal sign. So let's put this together. 4 more than is 4 plus. 3 times a number is 3n, set it equal to negative 26. Number 23. 24 is, don't forget is represents our equal sign. 6 less than represents subtraction. Twice a number is 2 times our variable n. But be careful with this. So we're going to start with 24 equals 6 less than twice a number, take twice the number minus 6. Don't forget less than. We're going to switch that order around. If we see less than, fewer than, shorter than, we're going to switch that order around. All right, finally, number 24 from this group. The quotient of a number, quotient means division again. A number represents our unknown, and 7. Increased by 6 means we're going to do plus 6, and then is equal to 12. So the quotient of a number and 7 is n divided by 7. Increased by is plus 6. Set that equal to 12. All right, let's move right ahead to number 25. Let's see some real word problems for this. I made the numbers really nice here. In real life, these numbers probably wouldn't be quite as nice, but I wanted to make it easy for our first endeavor into solving or writing and solving two-step equations. So number 25 says, Josh is saving money to buy a cell phone that costs $100. He has already saved $60 and plans to save $5 each week. A, write an equation to represent this situation. B, solve your equation from part A to determine how many weeks it will take for Josh to save the money to buy the cell phone. Your word problem that's on your quiz later on this week is very similar to this, so let's take a look at it. Start by identifying our unknown or what we're trying to find. It says determine how many weeks it will take for Josh to save the money to buy the cell phone. So what are we trying to find? Well, the number of weeks it will take Josh to save $100 for our really cheap cell phone. I know in real life that's probably more like $799.99, $999.99, but I wanted to make the numbers pretty easy for you. So let's define our variable to represent that. W is going to represent the number of weeks. Now let's write an equation for this. We know that he wants to save a total of $100. We also know that he has already saved $60 and he plans to save $5 each week. Remember that W represents the number of weeks. So we need to put our 100, an equal sign, a 60, a 5, and a W into an equation. So we know that 100 is the total cost. So 100 is going to be the number that goes by itself. We know he already has 60, so we can take the $60 he already has, plus the $5 each week that he's going to save. So that would be 60 plus 5 times W equals 100, a pretty standard way to set this up. We know that our variable W has to go with one of those numbers. Because it's $5 each week, the W goes with the 5. And we just add on that $60 that he already has. Now, I have seen students write this like this. they've written 100 minus 60 divided by 5 equals their variable W. This is fine, but you have to put 100 minus 60 in parentheses because you're going to do 100 minus 60 first and then divide by 5. Otherwise, order of operations would apply and you would divide and then subtract. So be careful. Let's go ahead and solve this two-step equation. The inverse of adding by 60 is to subtract 60. That gets us 5W equals 40, which makes sense because if we subtract off what he already has, he has $40, or he has $60, so he still needs to save an additional $40 for the total over the number of weeks. So we want to now divide both sides by 5 to figure out how many weeks it's going to take him to save that money. So we take 40 divided by 5 to get 8 weeks. Again, this makes sense because if he already has $60, he still needs to save 40. If he's saving $5 each week, take 40 divided by 5 to figure out how many weeks that's going to take. Don't forget a label on your final solution as well. If you're not sure what label to put on it, reread what you're trying to find or reread the question. Determine how many weeks it will take for Josh to save the money to buy the cell phone. Well, this is 8 weeks. All right, let's try another one like this. Number 26. Jasmine bought 6 CDs, all at the same price. The tax on her purchase was $7 and the total was $73. A. Write an equation to represent this situation. B. Solve your equation from part A to determine the cost of each CD. So let's identify our unknown. It says to determine the cost of each CD. Excuse me. I also realized that CDs are a little outdated and the numbers here again work out really nicely. In real life, a lot of times your tax isn't exactly one whole number or integer value. So let's define our variable to represent this. C is going to represent the cost of each CD. Now let's write an equation to represent this. We know that Jasmine bought 6 CDs. And we know they're each the same price. And C represents the cost of each CD. So this is C. We know the tax on our purchase, tax is something that's being added on, was $7. Excuse me, I got a tickle in my throat all of a sudden. The total was $73. So we're going to set this equal to 73. So we have to figure out which number the C goes with. Well, if C represents the cost of each CD and she bought 6 of them, why not write 6C plus the tax that she spent, set it equal to the total amount that she spent, which was $73. All right, let's solve this equation. So we're going to start by getting rid of that plus 7 by subtracting 7 from both sides. We're going to get 6C equals 66. Divide both sides by 6, and we will get a solution of 11. The question is, determine the cost of each CD. So in this case, each CD will be $11. All right, let's try another one of these. In question number 27, it says, Liana bought a DVR from her cable company. She must pay a one-time fee of $80. After 1 year, the cost of the DVR will be $224. A. Write an equation that can be used to determine the monthly cost of the DVR. B. Solve your equation from part A. Our unknown in this case is the monthly cost of the DVR. So let's define a variable to represent that. I chose M to represent the monthly cost of the DVR. What we know is that she needs to pay a one-time fee of $80, and that's not per month, that is just one time. We also know that after 1 year, so that's 12 months, the cost of the DVR will total $224. So that $224 is the total cost. It's going to be the number that goes by itself. We also don't have a number here that's missing for us. We know M represents the monthly cost of the DVR, and we're talking about the total cost after 1 year. Well, I've already said that 1 year is 12 months. So if M is the monthly cost, we need to multiply that by 12 for the 1 year period or 12-month period. Add on your one-time fee of $80 and set that equal to 224. So this one's a step harder than the last couple because the number 12 isn't given to you in the problem. But if we're talking about a 1 year period and M represents the monthly cost, well, that's 12 months. So take 12 times the monthly cost M, add on the one-time fee of $80. And anytime it says a one-time fee I'm trying to think of another way they put it. A lot of times it'll say a one-time fee of something. And you'll just add that on. That won't be per month or anything like that. Flat fee, that's the word that I was thinking of. We saw that in a performance task earlier this year. All right, let's go ahead and solve this equation. So we have 80 plus 12m. Start by subtracting 80 from both sides. To get 12m equals 144. Divide both sides by 12, and we get our monthly cost of $12. All right, let's finish with question number 28, our last word problem. I believe it's the last question from the notes. Yep. So number 28, the temperature is 12 degrees Fahrenheit. It is expected to fall $3 degrees each hour for the next several hours. You can tell this is the second time I've made this video after it didn't record. So part A, if the temperature is expected to be -9 degrees Fahrenheit after several hours, write an equation that can be used to determine how many hours the temperature fell. B, solve your equation from part A. So let's identify our unknown. In this problem, we are asked to determine how many hours the temperature fell. So I'll define a variable h. H equals number of hours. Now, what do we know? We know that the temperature began at 12 degrees Fahrenheit and it's expected to fall. So that means subtraction, and it's going to fall 3 degrees each hour. Keep in mind, h represents the number of hours. And it's going to end up at -9 degrees Fahrenheit. So let's put this together. It starts at 12, it falls, so we subtract off 3 degrees per hour is 3h, set it equal to our final temperature of -9. But be careful here, the variable for the first time in these questions comes after subtraction, so start by adding the opposite and write it as 12 plus -3h equals -9. Now, get rid of your plus 12 by subtracting 12 from both sides. So we have -3h equals -21. Divide both sides by -3, and we will get a solution of 7. -21 divided by -3 is 7. Our label here is not degrees, but hours, because we were asked to determine for how many hours the temperature fell. Again, realize for all of these problems, I made the numbers work out really nicely. In real life, you might get more decimal and fraction answers, but since this is our first time seeing these two-step equation word problems, we're going to make sure the numbers work out pretty nicely for you. We'll continue to reinforce this and solving two-step equations in class, but I did want to make sure you saw lots of practice problems on this here in this video. Thanks for listening.